kind of left superscript. Right? So that is the notation that I will stick to, so that hopefully it is more explicit. Because when the book doesn't say anything about the frame, they assume that that is the inertial frame. Okay, so and I find that that may be confusing sometimes if you don't write the frame explicitly. So what I will choose is that I will write the frame out explicitly, and typically in at least my notes, frame A will always cannot guarantee always. Sometimes I change notation. Most of the time, frame A is the inertial frame, and frame B is the rotating frame. Okay, so I think the next few slides will be a bit clearer. Okay, so just to go through things slowly, all right. So let me just show you the first first point of discussion. Talking about, is there a difference between a translating frame and a rotating frame? So what do you mean by translating frame? What do you mean by rotating frame? All right. So a frame. Okay. So before we go on and say what is a frame, a frame is just something like a coordinate axis. All right. A frame should have an origin, and then it should have its 3 unit basis vector to tell you how the frame is oriented. So for example, in this case, I put my origin here, and I say that the unit vector along x direction, little I is here to the right. Unit vector along y direction is upwards vertical. And of course, hopefully you can figure out that the unit vector along the z direction is pointing out of the box. Right? So these are the 4 things you need to know. The position of the origin, the 3 unit vectors, where are they pointing? So, but of course, I can actually make this frame translate. That means this frame can actually move. So if I start saying that, okay, if this is my frame, or this is my coordinate axis, or coordinate frame, I have a vector here called Q, all right? When I translate, or when I shift the frame, how does it affect my components that I can write Q in? Remember, we write a vector Q in terms of Q1i plus Q2j plus Q3k, right? We write the components in terms of the basis vector or the unit vector. So if I translate the frame, what do I get? All right, so if I move the frame, translate it, notice that Q1 and Q2 remains unchanged. So a translating frame does not change the notation of a vector. Right? When you write a vector down, it does not. Now look what happens when you start to rotate the frame. So if I start to rotate the frame, notice that when you start writing the vector Q, the components that you can write down starts changing. Right? So the important thing here is that, so nobody talks about translating frame. Right? So what if you translate the frame, whatever mathematics I write down or whatever equation that I write down for analysis remains unchanged. But however, when you have a frame that starts rotating, then whatever you write down at this moment may not be valid at the next moment. So that is why we spend so much time talking about rotating frame, because the rotating frame makes a big difference to the way that you can write down the equation, or makes the difference to the way that you can analyze the problem using some formulas. Okay? And as a side effect of that, I want to point out that because the translating frame, that means if you shift the origin, it really does not matter, or it does not affect the way that you write down the equation. The choice of origin is really not important for free vectors. All right? Notice that what I draw here is a free vector. All right? So what it means is that when I shift the frame around, just translating it, or if I just shift this vector, just translating it around, it will not change the mathematical form of the vector. All right? So I think I get a number of questions, I think last Tuesday and also before that, asking me where do you put the origin or things like that. So I have to say it again. All right? For free vectors, the choice of the origin is really not important, because the way that you write down the expression for a free vector is unaffected by the origin. And I always like to use free vectors. So notice that in all the formulas I gave, velocities are free vectors, accelerations are free vectors, angular velocity are free vectors, relative position vectors are free vectors. So notice that I didn't use absolute position vectors. Right? The equations that I use are all relative position vectors. So those are free vectors, and they are unaffected by the choice of origin. Okay, so as I said, something that I just want to point out. And of course, the second thing from this picture is that, so the orientation of the frame axis are the one that are important. Right? When you start rotating the frame, then you find that the coordinates that you write down for the vector will be different. So that's why almost today's lecture and next Tuesday's lecture will be set aside to talk about this rotating frame. Okay, so everybody okay with that? All right, so now we move one step forward. All right, so we're going to talk about what happens if you have a constant vector in a rotating frame. All right, so as a picture, let me draw something like this. Imagine I have either a plate or a cardboard or a piece of paper there. All right, and this is, of course, a rigid body. What I'm going to do is I'm going to fix a frame called frame B, and I stick this frame onto the piece of paper or the cardboard or the plate. At the same time, this outer one, you can think of it as earth or ground or whatever. So you can think about this is the ground or this is the wall. So this is the fixed thing, right? So this is like the whole earth, right? It is fixed, it's not moving. What I'm going to do is that I'm going to now rotate this piece of paper on this fixed ground, all right? And I want to show you what happens if we look at a vector, all right? This vector is kind of fixed on this paper. So you can think about, I go in, I draw a vector on this paper. So this vector is unchanged on this paper. But when I start to rotate this paper at that time, what will happen to the way I can write this vector? All right? Okay, so hopefully you can see what is going on. All right, let me just pause it here. So what happened just now is that we start to rotate this paper. So we actually have a rotating frame because frame B, which is following the paper, is of course now rotating, right? So now frame B is a rotating frame because it is rotating together with the piece of paper that we are trying to rotate, or it's rotating through space. All right, and if you look at this vector Q, all right, although this vector Q is, or this vector Q is fixed on this piece of paper, so if you look at how we write the components for Q in frame B, is always given by these two components in black. And those two components are always unchanged because vector Q is fixed on this paper. Frame B is also fixed on this paper. So no matter how the paper is moving around, if I write this vector in terms of the component basis vector or write in components of frame B, these two black components are always unchanged. However, because this paper is rotating with respect to the ground, this basis vector for frame A, which is the fixed frame, remains always vertical and horizontal. So you notice that the red component, that means if I'm going to write vector Q in terms of the basis vector of frame A, these two components will be changing, right? So if we let the animation run further, you look out for how the black components are not changing, but at the same time, the red components are always changing, right? In fact, the red component here is getting shorter and shorter, while this part is getting longer and longer. So if we turn it backwards, you can also see the same thing. Right? So look, the black components of this vector are always not changed. Whereas the red components are always changing. Right? In fact, when we go back to the original state when the unit vectors of frame A and frame B are aligned, the black and the red components of the blue vector, they are exactly the same. All right? So the important thing to see here is that when we have a vector, all right, even if the vector is not changing in frame B, all right, while frame B is moving, all right, the components, if you write in terms of frame B, will be unchanged because it is not moving with respect to frame B. But with respect to another frame, in this case frame A, the components of this blue vector will be changing. All right, and hopefully you can see now that this is the fixed frame, and this is what we call the rotating frame, right? The frame that is attached to maybe this